This is what's next on my list. Let's see if you and I can determine how we can differentiate the ratio to functions. So in my usual fashion, let's let k be equal to this. To differentiate using my definition, I get the limit of that difference quotient. Now let me just play. K's alternative name is this. Dare I say it again? Here goes. Oh, all of us pre-calculus experts understand the output of that function, if this is the input, is the ratio of these individual outputs. I'll apply the same rule to the second term. I knew I was going to struggle with my board space on this one. Okay, next on my list, I don't like how I have smaller fractions embedded in the bigger fraction. So if you don't mind, I'm going to multiply top and bottom of the big fraction by the LCM of the denominators of the smaller fractions. So in multiplying top and bottom by this g of x times this g of x plus h, here's what I get. Next on my list, I am now going to add a funky looking form of 0. And here's a form of 0 I'm going to choose. So slowly massaging everything. Would you not agree I get this? So with the first two terms upstairs, if I pull out a common factor g of x, here's what's left over. Now with the last two terms, if I pull out an f of x, split up the limit, trying to make sure I have enough room. And I'm not going to have it. Shoot. Now, a couple things. Number one, I did swap these two terms. So to make it legal, I will have a subtraction operation up front, and I did. And secondly, I completely neglected these two factors downstairs. But the limit of a ratio is a ratio to limits, assuming the denominator is not 0. I'll put it in. I think we're ready. So notice how this algebraic expression has nothing to do with h. So it's basically behaving as a constant with those limit laws. The limit of anything that does not involve h as h does anything that Darwin pleases is just that thing. However, the second factor of the first term is nothing more than the derivative for f. And over here, likewise, I have a minus f of x times g prime of x. Now downstairs, as h goes 0, I just simply get two factors, both of which are g of x. There is my quotient rule for differentiation. I will add it to my list. So let me say it out loud in English. To differentiate the ratio of two functions, I get what's downstairs as is don't touch, times the dirt of the numerator, minus the numerator don't touch, times the dirt of my denominator, all over that denominator squared. Again, I'll refer to this as my quotient rule. Now, it looks like I'm running out of space with my board, so I'll stop with adding to my list. But this list is so deficient. Let me just mention very quickly what we're going to do next before this mess is over. We're going to talk about differentiating the composition of two functions. In this first list, which involves the derivative of specific known functions, is hugely unsatisfactory. We need to differentiate trigonometric functions, inverse trigonometric functions, hyperbolic functions, inverse hyperbolic functions. We need to differentiate exponential functions with basis of the mean. We need to differentiate logarithmic functions. So we're so far from finishing this list this semester. Much more to come soon.